C2Gate introduction video. It's a simple video to show that how C2Gate briefly works, which I will release soon. C2Gate is a command and control communications platform, so it will simulate the malware traffic, but it needs information from you that can be collected using threat intelligence or similar environments. So this tool could be used to generate the malware traffic to test the data analytics as well as security incident detections environments. How we work on this tool is quite easy actually. We need to generate a profile for that malware. The profile is a simple communication environment. For example, this is a sample profile. We will choose some channels here. Those channels will be enriched soon. DNS-C2, DNS over HTTPS, and some other cloud integration protocols will be there. But currently, those four protocols allow me to simulate a lot of malware traffic in the wild. So this is HTTP, and we are actually setting a port. TLS could be enabled or not. Update interval is simply the beaconing ratio that we can adjust, and jitter will add some randomization on this beaconing ratio as well. HTTP URI and GET request types that could be used for building that custom profile. We can put a simple URI here. We can change the request type from GET to POST or even head. We can set the agent. We can add cookies, HTTP request headers or server headers for the response types, and we can add custom request content, response content, and also error content if the request doesn't match. This is the custom profile. I have generated four profiles here for just testing. They are based on HTTP, HTTP WebSocket, TCP, and UDP. The difference here is actually those three protocols, WebSocket, TCP, and UDP, are in real time. HTTP is not in real time. It is based on the HTTP request. So simply we need to add some beaconing ratio there. Otherwise, we don't need beaconing for the other protocols unless we need some certain types of traffic. Services are actually based on this profile, and we can add a new service using any profile. For example, we have four profiles here, and I can add fifth, maybe sixth service based on that profile. While adding a service, we can change actually the profile content as well. This doesn't change the profile. That gives us some flexibility, so we can change the ports for certain services. We can add different URLs, or we can add different headers for different implant types, but they are still based on the same profile. For example, this is based on TCP, and it gives us the content, but HTTP is way more rich because it has some headers and some additional content. When we add those services, we can start them, stop or restart them, so they will be running. Finally, we need to generate an implant to connect this, to generate this traffic, right? That's why we use generate implant for this. The implant name will be here, for example, implant 1, and description will be here. The flexibility here is we can build an implant based on one or all of those profiles. So simply we will generate a profile for it. For example, this implant will connect to those IP addresses, which are my local host currently, and it will use four of those services. So simply, those four services are quite important for us because our implant will be actually based on this. So there's a new implant, which is implant 1. I have previously generated also this test implant as well. What we can do with this implant is simply download this. As you see, there's a source code here, and it is specific to the implant. So you can copy paste this to your code, and you can build your own custom implant, or you can save this as a .NET project. So .NET project will help you to actually understand the content of it, and you can actually build this and use it. In this case, I used C2 implant here, and I'm just going through the directory of it, and the content is here. If we use .NET Run, .NET would run all of this, and we will receive some sample requests and responses. As you see, the implant is actually dumping the responses received from the server, TCP response, UDP response, HTTP response. They are available in this services section as you already said. So simply it sends this request, and receives this response. So simply you have a generator to build this traffic. Also, you can simply change implant beaconing ratio, the interval, custom per service per implant. That will help you to generate more traffic. Status screen currently debugs and gives information about the implants connected, and you can see what's going on the monitoring side. So this will work well on Mac, Linux, or Windows using .NET 5. The environment is developed using Blazor as well, so you can easily use this environment. I will actually prepare additional presentations based on how we can prepare malicious traffic simulations using this tool. But if you are still wondering how we can build some simulations, you can go to my previous projects such as TA505 Plus. You can go to GitHub and find my profile there. And after that, you will see TA505 Plus adversary simulation. And it has also some live videos actually recorded a lot of exercises and actions of it, more than 4 hours video. If you are also wondering a hostile C2, okay, Patak C2 is slightly hostile, even though it is developed for purple teaming. It has additional malware capabilities such as inline loading, the .NET assembly, process injection capabilities, and some additional tools that will help you to simulate some hostile behaviors. On the other hand, C2Gate is a defensive tool. It doesn't have any hostile feature. It's not a malware, and it won't generate a certain malware for you. It will only provide a traffic generator. So that's it. C2Gate will be with you shortly. I don't know how soon, but it is soon. It's almost ready to go as a proof of concept. Thank you for listening to me.